something changed the moment the new data arrived. The latest images weren't supposed to look like this. For weeks, astronomers predicted that 3I Atlas would quietly dim after its solar encounter, shrinking into a pale dot like every normal post-perihelion object. But the new frames showed the opposite. The object looked brighter, clearer, more structured, and far more active than anyone expected. At first glance, it seemed like a simple enhancement of the coma, but the details inside the light told a different story, one that no one was prepared for. When researchers loaded the raw RGB frames, something immediately stood out. In the red channel, the nucleus appeared compact, sharp, and surprisingly dense. In the green channel, the coma expanded much wider than earlier observations, glowing with a brightness that spread across multiple pixels. And in the blue channel, the object was strangely weak, almost silent. That imbalance alone was enough to raise eyebrows, but the real shock came when the spectrum was compared with these images. The green emission from the object matched a faint dip detected around 470 to 520 nanometers, exactly where C2 molecules normally leave the signature responsible for green glow. But the intensity didn't behave like typical comet activity. It rose and faded inconsistently, almost like something pulsing beneath the surface. When analysts processed the L-filter exposure, the raw, unprocessed one, the coma wasn't just visible. It was structured, spread out, stable, almost too stable for a fading object moving away from the sun. Instead of collapsing or scattering, the coma expanded in a controlled shape, unlike the chaotic behavior common after perihelion. That stability was the first sign that 3I Atlas wasn't following the script. Then the spectral scan arrived and everything changed. There was a spike in the mid-band wavelengths, subtle, thin, and sharp, but it should not exist. Not in this object, not at this stage. The spike sat right between the infrared and visible green spectrum, a region where nothing from 3I Atlas had ever appeared before. The signal was jagged, irregular, and inconsistent, almost like it was still forming. That is what froze the room for the scientists who saw it. Something was changing inside the object right now. Not gradually, not over days, but moment by moment. Usually, spectral fingerprints behave predictably. Dust produces smooth curves. Gas emissions produce clear, recognizable lines. But this object refused to match anything familiar. The spectral dip near the green band shouldn't have been so narrow. A growing coma should widen it. Instead, the dip tightened, meaning the freshly formed glow was thin, new, and recent. Something had happened to the object very shortly before these readings were taken. Across observatories in Italy, China, and Arizona, the same anomaly appeared. 3 different instruments, 3 different angles, same spike, same dip, same strange fluctuation. That eliminated the possibility of camera noise or calibration error. This phenomenon was real, and it was happening now. But that wasn't the only problem. When high-resolution brightness curves were examined, astronomers noticed an uneven stretch in the central light. Not a blur, not an artifact, a real distortion, like something inside the glow wasn't symmetrical. If dust was scattering, the pattern would be random. If gas was venting, the curve would widen smoothly. But this distortion had direction, shape, intent. Scientists called it anisotropic reflection, because that sounds safer and less dramatic than admitting the truth. No one knows what is causing the shape inside the light. The deeper the team looked, the stranger things became. The green glow was strong and growing. The red continuum increased steadily, suggesting warm material or controlled heating. And the blue ion response, almost non-existent. A comet after perihelion should blast out blue ion trails as solar wind strips particles away. But 3I Atlas refused. It stayed quiet in the blue band, as if the ion tail was being suppressed or never formed in the first place. Something inside the object reflected or absorbed light with an accuracy no natural fragment should produce so cleanly. Hours before, a new short wavelength rise appeared in the blue band. Very small, almost unimportant on its own, but when combined with the earlier mid-band spike, it revealed something unsettling. 2 temperature zones forming at once, a warm region and a cold region side by side, inside an object that should be uniformly cooling as it leaves the sun. That kind of temperature split doesn't happen unless something inside is cracking unevenly. releasing patches of heat, or undergoing a chemical reaction not yet detected. This is why scientists are no longer calling the new images beautiful or interesting. They're calling them unexpected, unmodeled, and active, because the object isn't fading. It's evolving, its structure isn't collapsing, it's changing, and the spectral fingerprint isn't calming down, it's becoming more complex. Meanwhile, something else quietly happened in the background. The United Nations announced an emergency simulation, officially unrelated to any cosmic object. But its timing, within hours of the spectral anomaly reports being shared across global networks, raised questions no one wants to answer publicly. Authorities claim it's routine, but astronomers familiar with near-Earth monitoring describe the urgency behind closed doors as abnormally high. For something supposedly harmless and distant, 3I Atlas is receiving attention far beyond standard scientific curiosity. The most unnerving development came from the brightness analysis. When zoomed in to ultra-resolution, the center of the halo was not a single point. It wasn't uniform. It wasn't round. It appeared stretched, as if something elongated was embedded inside the glow. Not a structure, not an object, but a pattern that should not exist in a natural debris fragment. Scientists carefully avoided any wording that could fuel speculation, but between us, the truth is simple. No one can explain it yet, and despite all this, the data remains consistent in one surprising way. The spectral fingerprint of 3I Atlas hasn't changed dramatically since early November. The same smooth red continuum, the same faint swan band dip, the same absence of major emission lines. Even after intense solar heating, the object behaves as if it maintains a stable internal composition. Normal comets fall apart, flare up, explode, or scatter. This one remains controlled, steady, almost disciplined in the way it emits light. As 3I Atlas moves farther from the sun, everything about its appearance should weaken. But instead, we see a stable coma, a growing green glow, and a red core that refuses to dim. It doesn't flare, it doesn't collapse, it simply continues forward, glowing in colors that shouldn't dominate in this phase, reacting in patterns that should not exist in deep space objects of this category. The new images aren't telling us that the object is dying, they're telling us it is entering a new phase, one we have never documented, a phase that carries a signature unlike any known interstellar visitor. Every new observation reveals another anomaly, another hint, another unanswered question. Something is happening inside 3I Atlas. Something that bends its light, splits its temperature, sharpens its spectral lines, and shapes its coma in ways that defy the expected behavior of dust and ice. The universe is showing us something we have not seen before, and whether this object continues to evolve quietly or surprises us again, one fact is certain. The story of 3I Atlas is not ending. It is just beginning. And whatever it reveals next may change everything we thought we knew about interstellar travelers and the secrets they carry when they enter our sky.